Good evening. My name is Shawn Gwin. I am a manager of software engineering at Higher Logic, and tonight's session is an introduction to the Go programming language. Before we get going, I just want to let you know that Higher Logic is hiring. Specifically, we're looking for a senior software engineer or software engineer, as well as cloud and data engineers. So if you're interested, please go and check the job listing at higherlogic.com, or feel free to reach out to me. I'd be happy to talk to you about those. So let's start off with a little bit of background on Go, a little history. It was originally created back in 2007 by 3 engineers at Google. These gentlemen were some of the pioneers in Unix, with creating some of the first Windows frameworks for Unix, as well as they created things like the UTF-8 standards. So they were very smart individuals, but they were frustrated with the existing languages that were out there. So C, C++, Java. They were frustrated with those languages because they thought it was way too complex to build simple programs. In addition, these languages didn't take advantage of some of the newer technology, as in the Intel multicore processor was just coming out. So they decided they wanted to write their own language. Their goals of the language was to make it so it was easy to program, or easy to write, efficient to compile across all platforms, and efficient to execute. So it took advantage of those multi-core processors where it could use parallelism and concurrency. All right, let's talk a little bit about where Go is being used. Primarily, it's being used for web applications and networking. That's its kind of claim to fame. But as the years have gone by, many people developed new libraries and have expanded the functionality of the language. And there's actually a place I'll share in a bit that has a list of where all the libraries that you could ever look for. So it's easy to find an existing library for any functionality that you want to build. In addition to it being an efficient language, easy to write, and uses and can be compiled across all platforms, there's also some other reasons why you might want to learn it as a developer. First, it is one of the top languages that is wanted according to the 2019 developer survey at Stack Overflow. In addition, it's the 3rd highest paying language in the United States. And also, it's tied with the 2nd highest paid language in the world. So because it is in demand and very well paid for, it might be another language you want to learn. Here are a bunch of different companies that are taking advantage of Go. Actually, Docker is pretty much written entirely in Go. YouTube, a lot of that streaming has been rewritten in Go. And if you go to that link, I got to stop saying Go for Go. If you click on that link or navigate to that link, it'll actually give you a whole list of different companies that are using Go, and they also have like blog posts of how they're using it. So it's kind of interesting to see the different areas that people are using the language. So how do you get up and running on Go? The easiest way, if you want to play around tonight with some of the examples I'm going to show you, you can just open up your browser and go to play.golang.org. And it's basically just a text editor. You might have seen these in other languages. And you can type in the commands and then hit run, and it will give you an output. The downside is you can't actually compile anything, so you can't create an executable for any platform, but it's a good way to start playing around. And if you want to install it on your local machine, you can just go to golang.org, and there's a big blue button on there that says download, and it will let you go and pick the engine that will work on your platform. So you just grab the one that works, like say on Windows, and there's a simple like MSI that you can install, and just runs through a simple installation. Or if you happen to be running Docker on your local machine, you can just go and grab a Docker image and spin that up in a container. So you don't have to install anything. But it's pretty easy to get the compiler and everything running on your system, one of these methods. And after you do that, you probably want to actually wire up some sort of development environment. So here's some of the most popular ones. Vim, VS Code, and Atom are free tools, and we're actually going to be using a variation of VS Code. I actually have it running, kind of speaking of Docker, in a little web server, but otherwise it's the same thing as Visual Studio Code. But JetBrains created this Golang down here. It was written entirely for the Go environment, but unfortunately it's not free. It's $200, I think, for a standard license. But what an IDE will give you over also running it through the playground at Golang is that it'll give you IntelliSense. So as you're typing commands, it'll actually help you complete the functions. So although you might try it out at play.golang.org, if you actually use it in something, say like VS Code, it's going to be a lot easier for you to get up to speed and kind of be more proficient at making the code. All right, so let's look at our first example of what a Go application looks like. And of course, you got to start off with Hello World because it's kind of a requirement for any new language you learn. First, we have packages. They are a way to organize your code into kind of logical groups. It's kind of similar to if you've used like C#. It's kind of like a namespace. And then we have the name of the package. If you're going to make an executable program, you have to have a package in your list that has a main name, because that tells the compiler, okay, this is where I want to start my executable. All other kind of names are really kind of considered libraries that you're going to use and not going to be executables. Inside there, we also have an import keyword. That's the same thing that we would have in Java or like a using statement in C#. This is just a way to reference external libraries. And then we have each library is going to be listed in quotes, and each new library is going to be on a separate line. And if you notice, there's no semicolons in this. This isn't like, so it's kind of hard not to type the semicolon, but everything is just delimited by a new line. Then we have our function keyword to designate that we have a function to run, and then we have the we have to designate main as the entry point for our executable, but we can create other functions without, in addition to main, that we can call. But this is the minimum that we need for an executable program in Go. And then if you see, we also have, we reference the library, this FMT, which is basically a format library, and it has its own print line. And then we add the text that we want to print. And of course, I'm breaking the rules by not making that world, but we'll mix it up a bit. So what I'm going to do is switch over and just show you it running in the browser. So here. So like I said, this is basically Visual Studio Code, and I created the same program. And this is actually a version of Linux that I'm running, so I'm going to go and create a terminal. And what I want to do is show you how to run these. You can simply, after you install the Go language on your machine, you can just simply type Go run, and then the name of the Go application you want to run. So this would be hello.go. When I run that, I get my results printed out to the screen. A shortcut way to run it as well, you can go run period, and it will run by default the file that's in your folder. Same results. And then a third way I can run this is I can actually compile this to an executable program. Again, I'm running this on Linux, so you're not going to see a .exe. But if I go run, go build -o hello app, and then again, I'm just going to give it designated. I want to compile the program that's in this folder, you'll notice up here I have a new file, hello app. If I was on Windows, it'd be helloapp.exe. And if I run this on Linux, I just go /hello app, and I get the same results. So simple program to run, simple. They said they want it simple to create and simple to compile, and it's very fast to run as well. So that's just a simple application to get us going. And we're muted, so if there's any questions in the chat so far, please let me know. Chris, can you let me know if there's anybody who has questions while we're going through this?
Yes, I will.
All right, thank you. So I'm going to continue on with the slides, because there's actually, as you can see, I have a lot of examples. I decided not to type these out so you didn't have to watch me type. So, but we'll go through each piece as we learn about the different pieces of Go. All right. So let's go through and let me bring up my notes here just so I don't get lost. We're going to go through basically how to set variables and how to play around with strings, and then we'll go back to the demos real quick. So there's multiple ways you can set variables inside Go. There are explicit ways, which you can say var num int, which would be the type of variable you want to set. So it could be string, boolean, byte. They have every variable type you can think of. If you set it explicitly without initializing it with a value, it will default to 0. And that's pretty much the case for all variables and different data structures we'll set. If you don't set a value, it'll set it by default to 0. We'll see that a little bit later as well. But if you want to actually default a value, you just add the equals to and the number, or I'm sorry, equals in the value you want to set it to. A shorter way is basically to drop the type and just do var variable name and then the value you want to set it equal to, and it will infer the type for that variable. But the shortcut way and the normal way is actually in Go is to basically do the declaration and initialization all in a shorthand syntax. So you basically set the variable colon equal to the value, and it will infer the type. And then we have easy ways to do converts. These are kind of similar in other languages as well. We have basically, if we want to do a float and then we want to convert it to an integer, we're wrapping it into an integer 32 function, and that will convert that into our integer variable. And then with strings, if I click on the right slide, then with strings, we have some simple manipulations. We can get like the length of a string. A string is basically an array of characters. So if we wanted to get the value of the string, the 6th position, so everything is 0 based. So it's 0, 1, 2, 3, 4, 5, 6. So we're getting the value of the W, which actually is a little different than some languages. It will return the decimal value of the ASCII character W. We'll see that in a minute. We can easily concatenate strings just like most other languages. We can use special characters just like C# and Java with \n, \t, a lot of the other escape characters. We can use backtick characters so that we can kind of format our string in line without any special escape characters. So these are some of the built-in functions for strings, but there's also a lot more libraries that are available that you can import to do all sorts of things with any kind of string manipulation you can think of. So given that, we're going to go back over to our demos. And again, I'm trying to run through these first couple because they're kind of similar to what you would see in every other language that you might have played around with. So if you go to variables, I'm actually going to kill that terminal here. If you go to variables, so basically we have the explicit type that we talked about, the inferred type, and then the declared and initiated value right here. And then what I wanted to do was show you how it's actually creating separate memory locations when you declare a variable in this way. So when we set number 4 equal to num3, it will give us the value 3, but then we're setting num3 equal to 4. So basically we're changing this guy to 4, but we'll see that num4 is still a value of 3. So if I run that, again, we could just go run period. You see that we did in fact change num3 to 4, but it didn't affect the number 4 or num4 at all. So that is a way to show that we actually declare separate memory for each variable. And then for conversions, we open up a terminal here. Again, simple example. We're going to set a float. Actually, I want to do this here. I want to show you something a little bit different. If you notice, I changed things by accident before. If you notice, I'm using the built-in print line function. So Go has a lot of simple functions that are built into the main libraries, so you don't have to actually reference any external libraries. So if we run this one, basically we're taking a float, we're converting it to an int like the example I showed in the slides. So we're going to go run. And if you see, we actually get scientific notation back when we print out the float. So it's fine if everybody is used to scientific notation. And remember that you move the decimal the number of places to the left or right. So that's great, but that's the reason why we might want to use an external library. And if you notice, I'm not wrapping the library reference here in parentheses. So if you only have a single library, you don't have to actually put that in parentheses and put it on separate lines. You can just say import just the one library. And so if I go and say fmt.println, and if you see I'm doing the code complete, we have a ton of different functions built right in this library. I'm just going to go and do println, and we'll take out the other one. And I'm going to leave the other print line that's built in because 1, 2, 3, 4 for the integer is fine. So if we just go and go run, we see it actually prints out normally. So that's just a quick example of why we might want to use the library as well, and how to do the conversion from float to int. And if you notice, I'm not using any kind of math library or anything like that to do the conversion as well. So let's go on to strings real quick. And let me do some housekeeping there. So again, this is another example of what we're seeing in the slides. We can get the length, we can get the decimal value of the 6th character here, which is W. We'll concatenate 2 strings, and then I put a tab in here as well, compared to the slides. And then also I added a tab here to show you we can do formatting with the backticks as well. So again, if we run this guy, you see basically we have the length of the string, which is 11. We have the decimal of 87 for W. We concatenated the 2 strings. We used the special characters to put a new line and put a tab. Then I did the same thing with the ticks. So you can do a lot of basic string manipulation again with the built-in functions that come with Go. But if you're going to do anything more involved, like doing index of and things like that, you're going to want to import libraries. And I'll show you where you can actually get a list of all the libraries that are available for Go as well. So, all right. So that is the simple stuff, so to speak. Now, what we're going to do is, let me check my notes here, please. Over here. There we go. All right. So, on to some more in-depth things. So, we're going to start getting into functions, and we're going to want to pass variables to our functions. The one thing that you might have to do a little differently than you might have done in other languages is have to use pointers. So this is kind of similar to C, C++, where you have to pass in a reference to a value of a variable, or actually to the memory of where the variable is stored versus passing in just the variable. So in Go, there's different ways you can, there's actually a straightforward way to handle the pointers to a variable's memory. So in order, we'll go through an example here in a minute, but like we have an add function. We're going to pass in a value, and in order to specify that we want a pointer to the memory of a variable versus versus the value of a variable, we would put asterisks in front of the type. So this tells basically the compiler saying I'm expecting a memory address versus a value. So then when we call the function, so say we set a value of I that we want to add. I guess that actually doesn't make sense because if we're only passing in one value, we're not going to add those. But anyway, say we have a value I that we want to pass into our function. We actually want to pass in the pointer to that function. So we prefix that with an ampersand. And I'm sorry, my font looks a little funny, but that is an ampersand and then I. And again, this will pass in the memory location where I is stored. It won't actually pass in the value of I. And then when we're inside our add function, we need to basically dereference that value. So we need to take the memory address and then grab the value from the memory that we want to manipulate. This will allow us to update a value that we pass in. Otherwise, if we just pass in the value and update it, it will not have any effect outside the function. So it's easier to see rather than kind of explain. So let me go back to my examples here again.
Before you do that, do you have a question, Shawn?
Yes, please. Oh, let me go to the chat. Hopefully, oops. Where is, I'm not seeing the chat. Oh, there it is. Sorry. Okay. Result in an integer 32 value of I. That's a good question. Shit. Let me just try that real quick. So the question is, if we get a value of, we get an integer value. Here, I'll let Andrew in when I'm here. So let me just quickly go down here and create a quick file. Test go. There we go. Package main, and we're going to go function main. Boom. And we're going to go like that, and we're going to print. So again, these are things you can actually go and play around with on play.golang.org, but we're here, so let's see what it says. This might not let us go, but we'll see. Because usually it does a pretty good job at catching errors. So we might have to actually set that to a value first. So if we go run, yeah, it's going to say it's truncated anyway. So what's nice about Visual Studio Code with the Go plugin, it actually does a lot of syntax checking for us. So if we go, we'd have to actually set that, I think, equal to so that will actually work. But it doesn't look like we can just do. So that being said, there might be a library that will handle that directly. So maybe not the int32 built-in function, but there might be some that are already in some other library that could actually handle that for you. All right. Does that work? All right. All right. So Amanda just put something there. Check that out in a bit. All right. I'm going to keep going. Let me actually go through the pointer example. So it's kind of still fresh in everybody's mind. All right. Let me kill that. So in my example, I'm setting a value, an integer value. Num1 is going to be 1, 2, 3. First, I'm going to pass it into a variable. I'm sorry, into a function that is only requiring me to pass in a variable by value versus they could say a pointer is basically you're passing in kind of a variable by reference. So what I'm going to do is I'm passing in num1, and then we're going to add 50 to it, and then we're going to print it out. And then we're also, when we come back out of the function, we're going to print out the value of num1 after the function. And then we're going to do the same thing, but we're actually going to pass it in as a pointer to the memory location of num1. So we're doing ampersand. So if you can see down here, I have an asterisk in front of the type. So that means I want a pointer, I don't want just the value. And then I'm passing in, I have to pass in a reference to the memory location of num1. And then again, I'm going to dereference the value of what is passed in. So basically I'm taking the memory location and dereferencing it and getting the value, and I'm adding to that memory location, and then we're going to print that out, and then again we're going to print it out afterwards. So if I run this, it should hopefully become apparent what we got. So again, if we go back here, we got 1, 2, 3, passing it into the mod without pointer. So we're just passing in the 1, 2, 3 value. We're adding 50 to it and printing that out. So we have 173. But when we come back out and look at num1, it wasn't affected at all. So then we do it again with passing in a pointer to it, and we add 77 to make it an even 200. So we print that out and we get 200 for the memory location. The of num1 is 200, and then when we print it outside, we get the same value. So it was updated. Num1 was updated outside the function. All right. Anybody have any questions on that? Let's back over real quick. Are we good? All right. Notice you can. Oh, cool. Thanks, Amanda. Awesome. Everybody did, okay, Chester saw that. Excellent. All right. All right, moving on from pointers, we're going to start getting into some data structures. We'll first start with arrays. Excuse me while I drink some water here. Arrays are similar to pretty much any language that you're kind of used to. The only difference with arrays in Go, again, is they will actually, if you do not initialize them, they will default to values, 0 values. And we'll see that in a minute. So if I create test with 7 elements, it's going to show an array of 7 zeros. And here I go and actually create a lotto variable that has 5 integers. And then I can go, it's all 0 based, so I can go 0 based and set the values of my lottery picks. And if anybody wins, please let me know. I want at least a cup of coffee. We can have different types. So again, shorthand would be to do the colon equals, set the array size and the type, and then we can set the values right within squiggly brackets. And then to read the arrays, it's the same as pretty much any language. We basically give the variable name with the index of the element we want to read. Or if we want to print out the whole array, we can just set it equal to, or print out just the array variable name. And we can do things like get the length of the array as well. One thing I skipped real quick, we have different data structures. Arrays are static lengths, so once we set them, you can't change them. We do have something called a slice, which we're going to talk about next, which lets us actually have a variable length array. But again, remember, arrays by themselves are just a single size array. You can actually, you can do multi-dimension arrays, but they're still going to only be a particular initial size. So let's talk about slices, because these two kind of go together. Slices are a way basically to have a dynamic array. You can use a slice to actually take pieces of an existing static sized array, or you can initialize a slice to be a different size, and you can actually copy from an array into a slice, or from another slice into a slice. So again, we have a static array, then we set the variables to that array size. That should actually be a 5 there. And then if we want to actually go and create a slice, we use this built-in function called make, where we say the type, we designate that it's an array of type byte, and then we have the length and capacity. So normally if you don't set the capacity, it'll actually default to the length. So if I didn't put the 6 there, it would be a slice the size of 3 and a capacity of 3. And I'll tell you about why we might want to set capacity in a minute. So if I print that out, it's actually going to just show me 3 zeros because I said the length is going to be 3. So it only initializes up to the up to the length of the array that you want. But I really have, in memory, I have the capacity of 6. So although I don't have 6 zeros, I only have 3 zeros. Why that's important is I can go and append to my slice. So if I go 1, 2, 3, I'll fill up the values of my array after the ones that are initialized. If I said 1, 2, 3, 4, it's actually going to go and create a new memory location for my S slice variable, and I believe it actually doubles the capacity. So that's just kind of a way, if you know you're going to have a lot of variables, a lot of values inside your array, you might want to set the capacity to the maximum size that you're going to work with, just so you don't have the destruction and recreation of your array in memory. Would kind of slow things down. And yes, as I said, if it exceeds, it will actually go and allocate new memory for your slice. All right, and some other things you can do with slices. Again, we're going to go and create an array with 5 elements. Then we're going to go and create a slice with the length of our array. And then we can actually do built-in functions like copy the array. What's different is you can't set D equal to S, because again, we're going to be pointing to the same memory location, versus if you copy, they're 2 actual separate memory locations, so you can update them independently. In addition to copy, we can actually take pieces of a slice or an array and create a new slice. So, for example, if I said I wanted to do a slice from 1 to 4, it's going to start at memory location 1 in the array. Array index of 1, so 0, 1. So it starts at 3, and it goes up to, but not including, the last integer. So it'll go 1, 2, 3, and not including 4. So we'll have 3, 5, 7. Shorthand is if I want to get just the first 3 elements, I can say just :3 and get me 0, 1, 2, and not including 3 on. So that's a shortcut to get the initial elements, first whatever elements you put here. And then if you want to get everything after a certain index, you can do the shorthand of just going the index colon, and that will give us, so we go 0, 1, so we go 2, 3, 4, basically 2 and everything afterwards. So again, first number, it's that index, and we include that index. The last one, it's up to but not including the index. So let's look at that in action here. Let me close down some of these real quick. And let's look at arrays. All right. So let's clear all those. So quickly in here, we're going to set an array of strings that are 0. And actually, I want to print out that array because I want to show you how it's initialized, even though it's a string. And then we're going to set the values for that array to those strings values. Here we are initializing an array with 5 integers, and here we are with initializing with 2 strings, and then how we can actually print them out and get the length. So let's just quickly run that. Simple. So actually, if you notice, there's no values inside here. It's basically 3 blanks. And then so we can print out the individual items in an array, and we can print out our arrays completely. And then we can get the size of the array. So that's pretty straightforward. And then we have our slices. All right, this one, I'm going to run through it quick. I kind of overdid it a little bit, but basically I want to show you that we can create an array. We can take a slice of our array. So these are actually the values we'll see after we read them. So it's just the same as it was in the slides. Then I'm actually going to update our other slice. So I'm going to update the 0 value, which we're going to update the 3 to a 0. And what we're going to see is we're actually updating both the array and the slice because they're pointing to the same memory location. So if you remember, I said you can't set it equal, you have to copy them in order to have them 2 separate ones. And then I'll set it back equal to, I'll set A this time, I'll set this guy back to 3, and you'll see it updated in B as well. And then we're going to go and just create an empty array, empty slice, and then show the capacity, and then we're going to append to that, show the shortcut of doing everything, the 4th variable, the 4th integer on, and then we're going to show a copy, and I'm going to update a value and show how they're independent. So doing that, go. So if you see, that's our initial array, and then our slice of the array. We updated the initial value, and it's 0, just like it was showing you with the comments. Same thing, I updated 3, and it updated both values. And then we initialized, we created an array, we created a slice that had the same length as the initial A array, so 5, and then I created capacity of 10. And you'll see the capacity there. I go and append 1, 2, 3, and then I actually pull back just the 4th value on. So basically 0, 1, 2, 3, 4, 5, 6, 7. And then I wanted to show that I had copied the array. So I copied basically 1, 5, 7, 9 into this array here. So 1, 5, 7, 9. I got 1, 2, 3. And then I just updated the value of the second one, the second index, and it didn't update A at all because we copied it. All right. I know it's quick, but anybody have any questions on that? We good, Chris?
We're good. We're good.
Okay, thank you. Sorry, it's quicker for me to ask you than to switch back here. All right. So now we are going to go on to structures. Structures are just a simple way to have a collection of variables. And an example is like a point, or you might have a customer with first name, last name, other demographics that you want to store with them. You can initialize them just with the values, or you can initialize them by prefixing them with the name colon. So if, say, you have a big structure and it's harder to actually put all the variables in the order, it's easier to actually kind of just set them with the name. And if you do not set them, they're defaulted again to 0 or blank. And then you can set them individually by using the dot reference, so .x, .name, whatever you want. And then you can also print them out with the dot reference as well. And then another structure is basically kind of like a dictionary in other languages. It's called maps. So basically we have key value pairs. And the way we designate those is we use the keyword, map, and then we use the type of your key, and then the type of the value that you want to store. So this one's actually going to store a string value for our coordinate structure. So we could add a string and an integer or whatever you want, kind of combination. Again, we have to make those before we can use them. So again, we use the make keyword, and same syntax, map string or map key type and then value type. And then we can use them in just the same kind of format here. So I can set the Albany coordinates equal to the latitude, longitude, and I can read those coordinates by just saying, give me m key name. So let's look at that real quick. I'm gonna close some things down here. All right. So let's go on to the structure. So for example, I have a structure that's just a person, and I give it a name and age. So I give it the value types separated on new lines for each variable type, or each variable inside of a structure. I can initialize it by just calling the structure and then with the values, or again, I could have just gone Bob and 42, and we had the same value. And I'll print those out. I can reference inside the structure. I can reference by the dot variable name. And then if I wanted to say create an array of people, I can go and create a structure, an array of structs with the types and initialize them. And then I can reference a particular one in the array with the dot name. So let's go and run that. So I'm going to go. So if you see, again, I'm just printing out the array. I'm printing out Bob, and I'm printing out the third was 0 based. So the third user's name in the array. So that's kind of straightforward, simple stuff. Just with structures, you can obviously make them more complicated than this. And then let's go to maps. So again, I want to show you too. If you're importing a lot of libraries and don't want to type out the full name, you can just prefix those with a short alias and then use those down here as well when you're referencing that library. I think I just saw somebody pop up there. So again, I'm giving a structure for coordinates, latitude, longitude. I'm declaring the variable for the map. I'm creating the map, so I'm actually creating the memory location. And
please unlock your device first.
and my phone thinks I'm talking to it. So then I set Albany's coordinates, and then I'm printing out Albany's coordinates, and I can actually do just get the longitude for those as well.
And you have another question.
Okay. Should I run this first, real quick? And then let me just run this real quick, and then I'll switch over to the questions. All right. So again, I'm just printing out the structure, and then I'm printing out just the longitude for the structure. Right. So is that array an array of anonymous structures or an array of persons? Let me go back to my array here. So, the structure. Oop, I had it. So it's actually, that's an array of anonymous structures. Is that your question, Casey? Yeah. So it's an array of anonymous structures. I tried to actually do an array of persons. I don't think I had the syntax right, so I just did the array of anonymous structures. I'm pretty sure there is a way you can actually do an array of structures that you defined before, but unfortunately I have time to go and figure the ins and outs of that one. Amanda chiming in. Oh, Amanda just shows right there. Okay. So if we have time at the end, or you can actually just, again, jump into the playground and try that out. But yes, Amanda knows what she's doing. Thank you, Amanda. All right, so let's go on to some looping and decisions. So basically kind of your if-else. The only difference kind of with a normal if-else is you don't require the brackets in Go. So if you're in another language, usually you say if and bracket, or I'm sorry, parenthesis, and then kind of your condition. You don't need that inside Go. You do need the squiggly brackets. And another difference with Go is that you can actually initialize a variable as part of the if statement. So say you want to get maybe the temperature, you can call a function and assign it to a variable inside the if and use that variable, but then it's only going to be alive in the scope of that if statement. It'll go away. So that's kind of a handy thing. Instead of going and declaring the variable above and then it kind of getting garbage collected at the end, this actually will get rid of the variable right after you're done with the condition. So that's a very handy thing that they came up with. And then if we go to switches, they are kind of a way to do multiple if statements together, like any other language that do switch statements. The difference between a Go switch and say some other languages is you don't actually have to put the break statement within the cases. By default, you're only going to run one case that satisfies the condition. If you want to run multiple cases, you can put a keyword called fall through, and it will keep going and run. It'll pass the control to the next case statement. So that's the only kind of difference with the switch statement that you would compare to most other languages. So let's look at those examples real quick. And so also, since Chris is recording this, remember you can actually watch this back later on and either play it at double speed if I'm going too slow or slow it down if I'm going too fast. All right, so here I'm actually going to use a new library. So there are a ton of different libraries, like I said, ones that are kind of supported within Go, and then there's a whole community that has libraries. And again, I'll give you a link that lets you go and search to your heart's content any kind of like database connectivity libraries you want to use or anything like that. Pretty much people have taken the time to write a lot of libraries. But this particular one, I'm just going to use it for the random function in math. So I'm basically going to give me a random number, seeding it with 100. And if it's divisible by 2, with mod 2, then it's even, otherwise it's odd. Pretty straightforward. So 81 is odd. Straightforward. And then if we look at the switch statement, a switch can have pretty much any type that you want. So I'm just basically doing a string. So I'm setting it equal to go to start, and then it's going to print out go. If you don't have any, if it doesn't meet any of the criteria, you can have a default value, and it will print, or I'm sorry, it will execute whatever's in the default case. And that magically it'll print out go. So that's pretty straightforward. So again, they're similar to other languages. It just sometimes they took shortcuts that aren't necessary. So there's no reason to actually put break in everything if you don't need it. So they were smart at how they figured out how to do shorter code in order to execute the same thing. All right. If there's no questions on that, we're going to go to for and ranges real quick. So for loops, pretty much for looping, for is the only context that Go has. So if you want a while loop, basically you got to do an infinite for and things like that. So for loops, again, are similar to other languages. You can initialize a variable, check the condition, and you can have basically a precursor, a condition, and a post process. But unlike other languages, you don't have to do parentheses around those, just like the if statements. And then if you want to jump out of a loop, you can hit break, or I'm sorry, you can add break to a condition inside the loop. And if you want to bypass a particular step in a loop, you can have a condition and say continue, and it will just go on to the next increment of your variable. And similarly, there's ranges that can iterate over a data structure. So with our arrays and slices, we have ranges, or we can use the range, and it will give us back an index value and the value that we're iterating over. So if I have an array of numbers and I say give me the range, one at a time it will give me back the index that I'm on and the variable, and I have to put those in to two different variables, and then I can use them. And we'll see that in a minute. Ooh. Let's go to the for and get rid of that. So here we're just initializing I with 1, and if we're just checking condition. If it's less than 3, then we print it out. Otherwise, we're gonna increment it until we hit 3. And then here's the normal way you kind of do it. So usually you go I equals 1 and then I plus plus, but that was just a different way to write it. So we got I equals 7, or J equals 7, J less than 9, increment it, print those out. Here would be a way to actually, if we didn't have this break, this would be a way to do a while. We could do a condition around this break and then exit the loop. But we're just going to go and print out one loop and then break out. And then our condition, or I'm sorry, our continue keyword is if we're on an even number, we'll continue and skip that even number, and we won't print that out. So it actually, from the continue, will go back to the for and get to the next increment of n, and then we'll loop through again. All right, so let's run that. Now it should be, again, hopefully straightforward. Good. All right. So again, we're just incrementing. We're only printing out 1 through 3, and then we're printing out 7 through 9, and then we're just printing out one loop, and then we're not printing out any even numbers here. That's that. And then with ranges, we are creating an array. We're going to increment over the array and print out the index and the value. And then again, we can do the same thing with strings, but the difference is, I don't know if I spoke of that, but for for maps, basically we have a key and a value versus an index and a value. So the key is, we'll print those out as well. You'll see that it returns back the key and the value. So it would be the string. Let me just run that and it actually makes sense. Okay. So our indexes and our values, and then we have our key and our value. So sorry, this is the key colon value, key colon value. That's how we're doing it for the map. All right. Any questions on that? We've got 3 more quick sections, and I'm hoping it shouldn't take more than 10, 15 minutes. And then we can let you go. So let's go on to functions. So functions are same kind of thing that are in most languages. You can take 0 or more arguments. Something different with Go functions is it's easy to return multiple results. And if you do return multiple results from a function, you have to handle those results. So you can't just say x equals something and the function actually returns x, y, and z. You have to handle that. If you don't need y and z, you can use something that's called basically a blank identifier. So basically instead of a variable name, you're going to put an underscore and it will ignore those values. If you don't do that, the compiler will say you're not handling x and y, or sorry, y and z. So you need to actually handle every variable that's being sent back from a function. And so the simple example is we'll add and multiply the variables that we pass in. So we're passing in a and b, and we're expecting back 2 integers. So this is the syntax where you basically parentheses of the variables you're passing in, and then parentheses of the variables you're passing back out. And you have to use the return key. Jumped in. You have to use the return keyword to actually explicitly send back the values from your function. You can't just let your function, by default, your function won't return anything without the keyword return. So in our example, if we pass in 5 and 8, I don't care maybe about the addition, but I want the multiplication. I would just put an underscore and then the variable name that I want to set the multiplication values back into. I'm just going to jump over to the demo of that. And so have a function down here. Basically, it's going to swap 2 strings. So I'm passing in 2 strings, and then I'm expecting to get back 2 strings. So I'm basically sending back b comma a versus a comma b. And I really don't care about, say, the first value. So I don't really care. Basically, b will get dropped. We get that return. So if let me just run it. It's a lot easier to see than me to talk. Go. All right. So up here you see I did swap string, and it's basically swapping the values as it should, because I didn't set it equal to something, but I would have it set to 2 variables and I can print those out. And here I don't really care about the first value, so I don't care about b. But if just to show you, if I just did this, it'll give me an error and say it expects me to handle the values. So that's why we have to do an underscore. And one thing I didn't mention, you can do debugging within Visual Studio Code. There's a bunch of actually tools you have to install, which so it'll install by default, but you can come over here and set breakpoints and actually kick off a run, and it will run through the code. It'll give you all the call stack, your watches, local variables, and you can step through your code. And if we mouse over that, I should be able to see the values and things like that. So I'm sorry I didn't get to show you that tonight, but it is built into pretty much all the IDEs you can debug. if you install the right tools. All right. Any questions on functions? We get one more piece.
You do have a question.
Okay. Can we use the blank keyword in for loops if we want to ignore key values? Yes, you can. That was easy, I think. Amanda, am I right? We'll see if she weighs in. Sorry, I need to take another drink. Yes. All right. We got the Amanda approval. So we're good. Awesome. Yeah. Again, quick overview of this tonight, but hopefully it'll give you enough to go jump in and look at it. And there's now motivation since Megan's offering jobs for it. All right. The last thing we're going to talk about really quick is Go routines. So I talked about parallelism and concurrency. Go routines are a way for you actually to kick off your functions to run in threads. So it's easy. All you have to do is put a Go keyword in front of your function. One thing that's, so you might say, okay, I'm just going to put Go in front of all my functions and this thing's going to run off multi-threaded. It's not the case. If you put Go in front of all your functions, the Go runtime is not going to wait for your functions to complete by default. So basically, you're going to spin these things off and it's going to end your program right away. There is a way to actually make it so it will wait for a return. The way we do that is we use these things called Go routine channels. So a channel is a way for you to actually pass variables between channels. I'm sorry, between Go routines. So I can create a channel, pass a value of X into that channel. I can read it from other Go routines, and I can read it from the main executable as well. So if I want to say, am I done? I can pass that into a channel, true or false, and I can check that, or I can wait until I'm done. I can check the channel to see if I have a true value, then I can exit. And basically you pass things in and read, you pass things in and you read from a channel by the direction that you set the basically less than dash value to. So this basically says, put the value of X into my channel. This says, set the value of Y equal to what is in my channel. All right. And then, again, just like slices and maps, you have to use the make keyword in order to create your channel. So with that, I will show you our last examples. We go back here and kill these guys. So let's go to Go routines. So of course I'm going to erase Chris because that's fun. So I'm going to kick off a function called race, and all it's going to do is go through a loop, and it's going to seed. It's basically going to, I'm seeding the random function with just a random time. And so I'm going to have different values for my integer, and then I'm going to basically sleep for that random time and print out a name. So it's going to go through, both functions are going to go through 5 times and then end. So first we'll run this the way it is now. So if I go run, easily Chris lost on purpose. So it'll 1, 2, 3. If you notice, I only ran 3 times, but Chris ran 5 times. The reason is that Chris's race was called synchronously, where mine was basically asynchronously. And again, if you remember, I said Go doesn't really wait for your Go threads to stop or to end. So as soon as Chris's synchronous function was done, it ended the program. So I say Go race, it's spinning off, and the runtime doesn't care about it anymore. It's just going to keep chugging along until it finishes the program. And if I did something like this, so we'll clear this out here. I could go run. You'll see it just doesn't do anything because it basically spins those two off and says, I'm done. I don't have to do anything else. So it ends. So in order to kind of mitigate that a little bit, we can use channels. So in here, I'm basically adding a series of numbers. So I'm going to say how many integers I want to add, and then I'm going to pass in a channel. So I'm making a channel of integers. So that's the values I can pass in. If you notice, I'm actually calling Go for both of my functions, and I'm passing in a reference to the channel. And then when I'm done adding my numbers, I'm putting the sum into channel. The reason why this program will end is because I'm waiting on the channel. I'm waiting for the values from the channel. So I'm setting the first value to A and the second value to B. I probably could have added another thing on here to say what one is what, but in theory, 100 is going to take less time than 200. So the adding 100 should end up A, and adding 200 should end up B. But something could happen where it could be different. So if I go, that's not the same terminal, the same location, go run. So they just kind of spun off and went quickly. So actually, it looks like the 200 finished first. Nope. That's consistent. I don't know why it's doing the last one first, to be honest. But Amanda. So anyway, I just wanted to show you that it doesn't end the program by just kicking off the two goes. I'm actually waiting for the channels. All right. And with that, I think I have given you the world tour in 108 minutes of, I'm sorry, an hour and 8 minutes of Go. So I'm going to leave this up. These are some really good references, and I can add the slide deck and the code to the link that Chris posts on the YouTube channel. But again, Golang is your first place you want to go. And the reason why they called it golang.org instead of Go is or go.org is because Go wasn't available. And also, it's a lot easier to search for Golang versus Go in search engines. If you want to see what libraries are available, or what, basically all of the libraries, all the popular libraries, I guess, are at package.go.dev. So it's a great search engine to go and type in any kind of library you want to look for. If you want to go through kind of similar, you might see some of the same examples, but Go by Example has good tutorials. There's examples on golang.org. There's the forum, the Golang bridge, where you can ask questions or basically see what other people have asked. And then that is kind of, that link at the bottom from GitHub is kind of a list of companies that are using Go, and you can go and look at the blog posts and see what they're actually using Go for. And that, as we say, is that. Anybody else have any questions? I'm going to move this over so we can leave that up there. Call for not paying attention. All right, thank you. So yeah, Amanda, the question was back on this guy. I'm not sure why it consistently finished with my second run of incrementing or going through a series versus the first one, but I'm sure there's it was consistently showing that the adding the 200 numbers was returning first, but I don't know if you know anything for the reason of that, but All right. Cool. Thank you, everybody. Again, Chris is going to post this, I think, up on the YouTube channel. And